Thing is about lap times and speed. You need to be fast, and to be quick on the straights, you need engine power, and to be quick around the corners, you need something called downforce. So downforce is basically that vertical force acting on the Formula One car. It pushes it against the ground and thus increasing the grip so you can turn the car quickly on the corners without any understeer or oversteer. So basically downforce is being contributed by all the aerodynamic components of the Formula One car, but mainly we are focusing on these three: front wing, floor and rear wing. To understand downforce, first you need to understand how does an aeroplane flies. So if that's the wing, when the wing moves forward, it's splitting the air into two components, one going above the curved surface and one going below the flat surface. So the one going above the curved surface with the velocity of v1 is greater than v2 because of the centripetal acceleration provided by the curved surface. So according to the Bernoulli's theorem, velocity is inversely proportional to pressure. So since v1 is greater than v2, that means pressure below the flat surface or below the wing is greater than the pressure above the wing. This creates a lift and thus the airplane flies. When we reverse this thing, we get Formula One's rear wing. We can see the flat surface above and the curved surface below. That means pressure above the wing is greater and pressure below the wing is less. So the force generated downwards by this setup is called downforce. Same thing happens for the front wing. We can see the curved surface below and hence downforce is being generated. For the floor, more velocity, more air passes below the floor of the Formula One car, acting as a suction, and this effect is called venturi effect, generating downforce. So we can see different setups being tried by different teams. The tunneling of the floor, we can see these tunnels provide channels for wind to pass at a higher speed. More speed means less pressure, means more downforce. So these are different setups like this one or this one of the front wing, the differences between the inclination. So in the first setup, more air would go above the car. In the second setup, more air would go below the car. That means more downforce is being generated in the second case and less downforce in the first case. So in a circuit like Monza where you need less downforce, you go for setup 1. In circuits like Monaco, you will go for setup 2 where you need high downforce. Now, why do we need low downforce? So basically, downforce comes with a price. There's a thing happening over here and we call that thing drag. So drag is a force which is proportional to velocity square and area. So this drag opposes the velocity of the car and slowing it down. So for example, if this car is moving towards the left, drag, which is when the air is being split by the car, some of the air is being accumulated over here and creates a region of high pressure. So this high pressure, and since behind the car there is a region of low pressure, so this creates a kind of force acting in the negative direction relative to the Formula One's velocity. So this will slow down the car. So to get the best lap time, you need a combination of aerodynamic, you need the combination of downforce and speed. More downforce means you are quicker at the corners, but you would be slow on the straights because it will slow you down because of drag.